Hello, viewers. In today's class, we are going to discuss another important problem from integral inequalities, right? So here in this session, we have an important integral inequality to be proved. So here we'll show that the value of this integral, that is pi by 6 to pi by 3 at tan x dx, is greater than or equal to pi times square root of 3 over 18 and less than or equal to pi times square root of 3 divided by 6, right? So here we'll make use of one important result from definite integrals, and then we'll see how easily we can prove this integral inequality. So let us start. So here we'll make use of one important result from definite integrals. Say if we have a function, say y is equal to f of x, which is a continuous function in the interval a comma b, right? It means x lies between a and b. Now see if this function f of x has m as its global minimum, that is absolute minimum value in this interval, and the capital M is the global maximum of this function f of x in this interval. It means it is the absolute maximum, right? So we'll confine ourselves to the limits, that is from a to b, and between a and b, including a and b, if f of x has small m as global minimum or absolute minimum and capital M as global maximum or absolute maximum, then we have this important inequality, that is m times b minus a is less than or equal to the integral a to b f of x dx is less than or equal to capital M times b minus a, right? So we have this important inequality, right? So we'll make use of this inequality to prove this result. So let us first denote this integral by I, right? So we have I from pi by 6 to pi by 3, and here we have 10x dx, right? So now this integral is our this integral, that is a to b, and we have f of x dx, right? So a is pi by 6 and p is pi by 3, and f of x is tan of x, right? Okay, now let us first find the difference b minus a. So b minus a is pi by 3 minus pi by 6. So we can take the LCM here. So we have 6, then 2 pi minus pi, that is pi over 6, right? Now our aim is to find out this small m and capital M, right? And we have the interval that is pi by 6 to pi by 3, right? So small m is the absolute minimum of this function tan x in this interval, and capital M is the absolute maximum of this function tan x in this interval, right? So in order to find out the small m and capital M, let us investigate this function f of x is equal to tan x, right? So let us find out the derivative of this function tan x. So the derivative of tan x is secant square x. So we see that this quantity, that is secant square x, is always a positive quantity in this interval, that is pi by 6 to pi by 3, right? Because here we are in the first quadrant, because pi by 6 to pi by 3, it lies in the first quadrant, and in the first quadrant all the trigonometric functions are positive, right? And moreover, here we have the square of secant x. So square of secant x is always a positive quantity in this interval. So we can conclude that the derivative, this derivative is always greater than 0 or positive in this interval, right? And whenever the derivative is positive in some interval, we can conclude that the function is the increasing function in that interval, right? So we see that this function tan x is an increasing function in this interval, right? So when the function is said to be increasing function, it means this quantity, right? This quantity gives us the absolute minimum value of the function tan x, right? And this value, that is pi by 3, gives us the value of capital M, which is the absolute maximum value of this function f of x, right? So now M can be obtained by taking x is equal to pi by 6 in this function. So we have f of pi by 6. So f of pi by 6 is tan of pi by 6. This is tan 30 degrees. So this is 1 over square root of 3. And the capital M is given by f of pi by 3. That is tan of pi by 3. So this is tan 60 degrees, which is equal to square root of 3, right? So once we have obtained the value of small m and capital M and b minus a, let us substitute all relevant values in this inequality. So now we have small m as 1 over square root of 3. B minus a is equal to pi by 6, right? And we have the integral a to b is pi by 6 to pi by 3 tan x dx, and here we have capital M, which is square root of 3 times pi by 6, right? B minus a is pi by 6. Now let us rationalize the numerator and denominator here. So we have pi root 3 over 6 root 3 times root 3, and here we have this integral as I. So we have here pi root 3, pi times square root of 3 over 6, and here we have root 3 times root 3 is 3, so 6 3s are 18. So we have pi over 18 is less than or equal to I, and here we have pi root 3 over, here we have pi root 3, and here we have pi root 3 over 6, right? And this is our desired inequality, right? So viewers, this is how by making use of this useful uh, inequality, we can arrive at these kind of integral inequalities.